Velocity is on the verge of stabilizing its magnitude, the final stabilized velocity is the terminal one. Stabilized velocity means constant velocity, and constant velocity means F net equals 0. Does any of our model predicts any terminal or stabilized velocity? Let's see. We made some minor changes in our Python files about graphical representation and data exportation. With the data we gained, we make graphical representation of velocity at y-axis, the y-axis component, versus time. As you see here, the freefall model does not predict any terminal velocity, while the two others do predict terminal velocity, and the quadratic drag force model predicts that this happens sooner than the linear drag force model. Let's explain it mathematically. Well, demanding that freefall model gives a terminal velocity leads us to expect that weight is 0, but this does not make any sense. On the other hand, quadratic viscous drag model leads us to have some terminal velocity. If we solve this simple quadratic equation, we find out that the magnitude of the terminal velocity is about 3.93 meters per second. Let's run our code to prove it. Well, I estimate that this happens when t equals 1.3 seconds. Running the program, we found out that the graphical representation of velocity versus time gets stabilized, as you see here, and the final terminal velocity is about, the magnitude of the terminal velocity is about 3.916. Not a bad estimation, I suppose. What if an object is thrown downward? Does initial velocity affect velocity's behavior over time? We can distinguish, as you see here, three different cases. In the first case, where initial velocity is less than its terminal value, our object accelerates through time until its velocity gains its terminal value. On the other hand, where initial velocity is equal the terminal velocity, which is minus 3.9, the two vectors of weight and drag force leads to F net equals 0, and our object has velocity which remains constant over time. Whereas, in the third case, where initial velocity is greater than its terminal value, let's see what happens. Initial velocity y component minus 10. Let's run our program to find out what happens. Wow, drag force initially is greater than the weight. Finally, is equal than the weight. Well, velocity initially decelerates up its terminal value. The three different cases are there. In the last case, F net has the opposite direction. This explains the decelerating behavior of our velocity. Thank you for listening.
Δώσε. Περιμένω τώρα.